Hi everyone, welcome to Atomic 60. On our today's lesson, I'm going to explain how we are going to determine the derivative of these natural logarithmic functions in general. So, before we're going to find the derivative of this problem, if you are a new member of my YouTube channel, don't forget to share, like and subscribe Atomic 60. Well, now let's see how we are going to determine the derivative of these functions generally. So, let me explain how we are going to find the derivative of the first function. That is going to be ln of x into x plus 1 raised to 5. So, in order to determine the derivative of this problem, first you have to look how we are going to determine generally ln of any function g of x in general. Is that what's the derivative of this problem? That means in order to find the derivative of this problem, the derivative of ln of g of x means whatever g of x in general this may be, whatever this function in general. In order to find the derivative of this problem, the simple formula for this is going to be the derivative of g derivative at x over g of x will be the derivative of this function. Is that? So, based on this rule or principle, we can immediately find the derivative of this one. So let's recall this as y, is that? And let's find dy by dx, is that? So dy by dx is given by, now the derivative of this problem, as I have already mentioned here, it is given by x into x plus 1 raised to 5 the whole derivative over what? Itself the function. X into x plus 1 raised to 5. So this is the derivative, is that? And you know that how we are going to find the derivative of the product. Look, the numerator is a product of just some power and one function. For example, if we have the function f times g, what will be the derivative of this one? So the derivative of this problem is given as f derivative times g plus f times g derivative. That means if we just find the derivative of the first, second will be written as a product of f derivative times g plus f times second, the derivative of the second function. So we call this product. So based on this principle, the derivative of this problem is given by the derivative of the first x derivative into x plus 1 raised to 5 plus x should be written as this is times x plus 1 raised to 5 the whole derivative over what? That is x into x plus 1 raised to 5. This is the way how to find the derivative of this function. And then when we just find or simplify the final result, let's bring this here. Is that? So this is going to be what? This is given by derivative of this. The derivative of x is simply 1. Is that? The derivative of x is 1. You know the reason how it is 1. For example, x derivative means, x means x raised to 1, the whole derivative. So 1 should become as a coefficient 1 times x raised to 1 minus 1, which is 1 times x raised to 0, and this is always 1 times 1, which is already 1. So because of this principle, x plus 1 raised to 5. That means the first, this part will be x plus 1 raised to 5 plus, to find the derivative of the second. Now in order to find the derivative of the second function, that means x plus 1 raised to 5. For example, if we have again the function f of x, which is given by x raised to n, f derivative at x is going to be n times x raised to n minus 1 times what will be the derivative of this one? The derivative of x is already 1. So the derivative is going to be this one. So with similar principle, with this case, we can just find the derivative of this written as 5 into x plus 1 raised to 5 minus 1 will be 4. Is that? Times the derivative of x plus 1. Derivative of x plus 1 is obviously 1. So it's no need to write it again. Then over now x into x plus 1 raised to 5. Is that? So this is a derivative of ln of x into x plus 1 raised to 5. So here, now this is given by generally divided by the x, is that? Which is immediately given by this. You can take out x plus 1 raised to 4 as a common for both sides. Here, when we take out x plus 1 raised to 4, now what's left here? We left only x plus 1 plus what's left here? Only 5. And we have this one over. So this is given by what? X times x plus 1 raised to 4 times x plus 1 again. We can describe this way. That because you know why? X plus 1 raised to 4, x plus 1 raised to 1 mean it's the same to this one. So immediately this will be, now this is cancelled by this one. Is that? So the final result will be x plus 1 plus 5. Then this is exactly x plus 6 over, now this will be x squared plus x will be the final solution of this problem. So, do you have any question how we do this kind of problem? If you have any question regarding of solving this kind of problem, please write your comment under the comment box. Is that? So, now let's see how we are going to find the derivative of this one. This is generally the derivative of this function. Is that? This natural logarithm ln of x into x plus 1 raised to 5. So let's continue how to do the second problem. Look how we are going to find the derivative of the second problem. I think here, let's recall again. Now let's recall this as y is equal to, let me write here just now, let me write here y is given by ln of square root of 10x squared minus 1. Is that? Minus 1. Then how we just find the derivative of this problem? In order to find the derivative of this ln of square root of 10x squared minus 1, first let me remind you again how we are going to find the derivative of this function. Let's assume that if we have the function y, which is given by the square root of g of x, how we define the derivative of this one? So this divided by dx means immediately you can take out this as, immediately you can find the derivative of this g derivative as x over twice of radical of g of x itself. This is the principle. So having this, let's find the derivative of this one. And I have already said before, if there is a function that is given by ln of, for example, f of x, if this is the function again, divided by dx is going to be what? F derivative as x over what? Simply f of x. Is that? So combining this and this one, we can find the derivative of this problem. And before, now derivative of this function is given by divided by dx is immediately given by the derivative of this one. That means the square root of 10x squared minus 1 over the whole derivative over radical of itself 10x squared minus 1. This is the derivative of the function. That means in the first step I have been applied just the principle of the natural logarithm ln of f of x. Ln of f of x. Thereafter I have to apply this technique in order to find the derivative of this one. Again, this is given by, which is given by the derivative of this means that take out simply 10x squared minus 1, the whole derivative over 2y of radical of itself 10x squared minus 1 times this value in general, that's the denominator. That means it will be times 1 over square root of 10x squared minus 1. This is the way how we are going to find the derivative. And then finally, here look, what's the derivative of this one? The derivative of this means, for example, if we have the function that is given by f plus or minus of g, the whole derivative, if we have the sum of the difference of two functions, the derivative of this is given by f derivative plus or minus g derivative. Is that simple? And then, because of this principle, what's the derivative of 10x squared minus 1? The whole. This will be given by, it is immediately given by, the derivative of 10x squared means, you can take out this as 20x, And the derivative of any constant is 0. So over the product of this one. What will be the product of this one? This is immediately 2, let me write here again. Now this result is given by immediately like this. So finally this is simplification for this problem will be dy by dx. Dx is given by 20x over the product of this one. That means 2 into the square root of 10x squared minus 1 the whole square. Is that? Because these times this means you can take same. You know the principle of this one. For example, radical of n times radical of n will be what? It is written as square root of n times n, which is the square root of n squared. So with this principle, we can just do this problem in the form of this one. And finally we have these. So now we have this case, see that? But now from here, finally, it's a matter of simplification again, is that? A matter of simplification. So how can we simplify this problem? Let me explain one very important point. For example, how to simplify, for example, this one. What is the square root of x squared in general? How can we simplify this one? And this will be, can we say that this is exactly x? Can we say this one and this one are the same? I think it's impossible because look this one. The square root of x squared means that for any real number x, if you take any real number in place of x, and when you just square it, this is always positive. So square root of this is positive. That means these are not the same. Is that? These are not the same. Because you know what? This is always positive. Is that? This is always positive and 0. Is that? But when you come to the case of this one, under the set of real number, this is always positive and 0. But when you come to the case of this problem, x means when you plug the same value here and here, for example, if you plug this one, negative 1, the whole square, x not equal to negative 1, is that? I have plugged negative 1 here, so negative 1, the whole square will be this one, is that? And this one will be negative 1, but this is the square root of 1. The square root of 1 is not equal to negative 1. The square root of 1 is 1. They are different, is that? So because of these cases, so the simplification for this problem will be 20x over 2 absolute value or modulus of 10x squared minus 1. Is that? The modulus of 10x squared minus 1 or 2, because this will cancel by this one. When you eliminate the symbol of radical, now this will be absolute value, because this will be, there is a possibility this will be negative and positive. And so because of that, it should be positive because it's under square root. When you take out any positive real number from the square root, it is positive, and because of this, I have to insert this symbol of absolute value or modulus. And so now when we simplify this one, 10x over what? Modulus of 10x squared minus 1. This is the perfect solution, is that? This is the perfect derivative of the given problem, is that? So, this is all about our two-less lesson. Maybe again, if you are a new member of my YouTube channel, please don't forget to share, like, and subscribe. It's almost 16. Thank you for watching. Bye-bye.